This is a video about domain and range of continuous graphs. Take a look at the graphs on this page. All four of these graphs have the domain of all real numbers and the range of all real numbers. Notice that this graph has lines that are going to just continue on and continue on forever, continue on forever. That's what those arrowheads tell us. And the direction they're going, since it's kind of diagonal, so it's going both down and to the left, and then up here it's going both up and to the right. Okay, so then I take a look at this next line, and it also is continuing down and to the left, up and to the right. It wouldn't matter if the line was going a different direction. It could have gone that way, and that still would have been all real numbers both directions. Well, I guess this graph says that exactly. So it doesn't matter if it has a curve in it, like this graph down here at the bottom has this cubic curve there. It's continuing up forever, down forever, to the right a little bit each time, and the left a little bit each time. So all of these graphs have a domain of all real numbers. Another way to write that is this large R with like two upper parts. So either one of those are good answers. And it also has a range of all real numbers. Another way to write that is the R with like a double line. Okay, let's look at the next set. So these ones at the top, they're opening down and they're opening up. So when you think about their domain, their x values are going to be any number on the x-axis, because this just continues to go downward, but also to the left, and this continues to go downward, but to the to the right. It doesn't matter if the graph is facing down, like this one is, or like this one is, or if it's facing upwards, like this one is. It doesn't matter. Both of those have a domain of all real numbers. Now that's not the range too. Now let's juxtapose it with these three at the bottom, and I'm going to draw a line here so we know that these are two different things. So these ones at the bottom are opening to the right and to the left. So what they have in common is they all have a range of all real numbers. All three of these, if they're opening to the right or the left, they have a range of all real numbers. So let's go back up to the top, and let's think about what values would be okay to use. Now, one of the things that I've done with my kids in the past was we would use a highlighter. We would highlight where it's okay to have the values. So it's okay to have the values starting here at the top of that parabola, and then all of these y values. See, what I'm doing is I'm coming down along the y-axis, and I'm just highlighting where all the values of y are okay. And I could do that on this one too. It starts right here at the vertex, and then I go upwards, and all of those y values are okay. So how do we write that? We write that by saying that the range, so we use R and then a little colon there, and we're talking about y's because it's the range. So I'm going to put y, and over here, same thing, range, and we're talking about the y values, and there is a limit. That limit is right here at the top. Okay, so they can have no more than, let's say, 1, 2, 3, 4. That's up at 4, positive 4. And the numbers that are okay are all less than. So we're looking at numbers that are less than. And so we're going to say less than or equal to, because it's okay to be at 4 as well. That's where it starts. Now over here, our limit is down here at -2. So I write that number. And then it's all values that are bigger. So all values that are bigger up here. So I'm going to say y is greater than or equal to negative, a better -2. Okay, now let's come down here and talk about these ones that are kind of like flopped over. So we already said their range is all real numbers, but each of them has a different domain. So the domain for this one, first of all, when we talk about domain, we're talking about x values. So I write x. Then I'm going to look at what values are okay. So get my highlighter here and highlight what values are all right to use. So I start here and then I just keep going this direction. So I'm hoping that this kind of reminds you of what the Desmos graph looks like when you type in an inequality in Desmos. Again, here we're going to start and then we just continue with values in this direction. Here we're going to start, but values are going in this direction. So we just completed the inequalities unit, and in that unit, we use Desmos to look at our answer. So I'll go back to that towards the end of this. Okay, so what value is okay to use? It looks like -1 is okay to start with. And then it's all numbers that are greater than or equal to 1. Then on the second graph, we have x. Always have x when we're talking about domain. And it looks to me, I'm just going to erase a little bit so you can see very clearly. It looks like it's at -2. So -2 is my number. And because it's opening basically to the right, all these values are greater than -2. And then this one, we've got x as our value. Looks like it's crossing at +2, but it's less than or equal to the 2. Okay, so that's how those work. Those ones have one that is are all real numbers, and then they have a limit for the other one. Now here's another type. These have different types of limits, okay? So in the circle, if I use my highlighter tool and I highlight what values are okay in the circle, well, there's here. Let me move that over. Okay, we've got this from here to there and from this spot to this spot. So all of these values that are represented by this highlighted square are okay to use for the x's and the y's. If we were to do the same thing for this one at the end, it's a little easier to understand than the middle one. Okay, that's the limit, that's the limit, here's the limit, and here's the limit. And it's where it's crossing that we want to get the numbers of where it's crossing on the x and y axis. Okay, so that's a little bit easier to understand. Let's do the numbers, and then we will come back to this middle one, which is, I don't know, just a tiny bit more complicated. Okay, so when we're talking about the domain, remember we've got domain and we've got range. So with the domain, the value is x. With range, the value is y. I put that right in the middle. Now, I'm going to look at the lowest value for the domain first. So the lowest, first of all, we're on the x. We're on this x-axis here, okay? And we're going to talk about the lowest value. So that is at -2. So I put that over here. And then the highest value, so I'm like drawing my pencil over to this highest value, and that is crossing at 1, 2, 3, 4. So I put the number 4 there. Okay, and now my inequality symbols, because I went from the smallest to the biggest, I can feel comfortable just writing my inequality symbols right in like that. Sorry, that's a little weird. There we go. All right, so the range though. The range, we're talking about the y-axis, and so we are talking about right here where it's starting. It's starting at 0, that's the lowest, and then the highest. Always we go to least to greatest. 1, 2, 3, 4, 5, 6. It's up to 6. And then since I did the lowest to the highest, the smallest to the biggest, now I can feel really comfortable writing my inequality symbols like that. Okay. And what this says here is that y is greater than 0, but y is less than 6. That's what that states. Okay, let's come over to the last one. We've got our domain and our range. So domain is x, range is y. Now, smallest x value that's okay is down here on the end, and that's going to be 1, 2, 3, 4. Negative 4 is where it's crossing. Right here is where it's crossing the x-axis. And then it's crossing the x-axis right here, and that's at positive 1. And symbols, just fill those in. The y values. Okay, the lowest is down here at negative 2, and then the highest is up here at 3. So I do negative 2 to 3, symbol, symbol, done. Okay, now we got to talk about this kind of oddball. And I'm going to get out the highlighter. Okay, so there is a limit to the x values right here. They don't go any further, but these x values are okay to use, right? Okay, so let's just write the domain right now. So the domain, it has one limit, but notice that on this side over here, it's just going to keep going and going and going. So it only has one limit. So I'm only going to have one inequality symbol. And you can do this in a variety of ways. Here's one way to do it. If you got comfortable like putting the variable in the middle and then doing that procedure over and over again. Let's put the variable in the middle. Okay, let's take the lowest. So the lowest was, let's see, 1, 2, 3, 4, 5. That's over at negative 5. And there is no highest. So I'm going to leave this space right here. I'm going to leave that space blank because there is no value on that side. Okay, now I'm going to draw my inequality symbols just like I always have. They're always going the same direction. Now, what if your answer is shown with the x coming first? Well, that's fine. You just need to do a pancake flip, okay? So it was open to the x. I put x and negative 5 down here. This is if you needed to rewrite it because it didn't match your answer choices. Now, it wanted to eat the x, so it still wants to eat the x. It's open to the x. It stays open to the x. Okay, so that's how you rewrite. But let's do range. So I'm going to erase this, and then we want to just think about the range. Maybe we will use a different color. And we're talking about y values now. So it crosses the y-axis right there. And then it continues up this way. Now it's flattening out, but we know that this is really going to just continue on and continue on. See how it's getting up higher all the time? Yeah, it's just going to continue on that way. And so we're filling in, right? So we're going to show our range as a y value. And then we do the smallest first. So it crossed down here, and that was at 1, 2, 3, negative 3. Now, it never stops on the other end. There is no limit on that other end. So we're going to leave the rest blank and just write our inequality symbol. And that is it. That is how you do that kind.